Hello everyone, welcome to my channel Chemistry is Fun. Today we will see part 2 of alkyl halides, and these questions which we will discuss today will help you in NEET 2024 examination. So I will be discussing some important points along with their explanation. The first one, alkyl halides are polar in nature but are insoluble in water. At the same time they are soluble in organic solvents. Okay. So why this is the situation? Alkyl halides are polar but they are insoluble in water. Their insolubility in water is due to their inability to form hydrogen bonds. What is the cause of insolubility? Their inability to form hydrogen bonds with water molecules. The reason is inability to form hydrogen bonds with water molecules. Okay, since they are unable to form hydrogen bonds with water molecules, or we can say they are unable to break the hydrogen bonds already exist in water molecules, or we can say unable to break the hydrogen bonds already existing in water molecules. So if you know the reasoning, you can answer the questions very well. The next one, their densities decrease in the order iodide greater than bromide, greater than chloride, greater than fluoride. So the densities decrease in this order. Alkyl bromides and iodides are generally heavier than water. Okay. Alkyl bromides and iodides are generally heavier than water. Methyl iodide is the densest alkyl halide. This is very important related to this. Methyl iodide is the densest alkyl halide. This is the densest alkyl halide because you see in this compound, contribution of iodine density is maximum. Contribution of iodine density is maximum relative to the contribution of hydrocarbon part. Okay. So as we have seen, alkyl bromides and iodides are generally heavier than water. Chlorides and fluorides are lighter. And methyl iodide is the densest alkyl halide because in this compound, contribution of iodine density is maximum. Methyl iodide is the densest alkyl halide because contribution of iodine density is maximum relative to contribution of hydrocarbon part. Next important point, the boiling points of chlorinated derivatives of an alkane increase with number of chlorine atoms. Okay. Boiling points of chlorinated derivatives of an alkane increase with number of chlorine atoms. Because there is an increase in the induced dipole attractive forces. So this is the reason. This is because of increase in the induced dipole attractive forces. So because of increase in the induced dipole attractive forces. So I repeat again, boiling points of chlorinated derivatives of an alkane increase with number of chlorine atoms because of an increase in the induced dipole attractive forces. Next important, stability order of alkyl halides are Rf greater than RCl greater than RBr greater than Ri. So Rf greater than RCl greater than RBr greater than Ri. So this is the stability order of alkyl halides. Now see, in this we can also say that the stability will be just the opposite of reactivity. Highly reactive means they will be less stable. If they are more reactive, their stability will be naturally less. Alkyl fluorides are less reactive than chloride. Okay. So here alkyl fluorides are less reactive than chloride because size of fluorine is smaller than chlorine. So the bond length of the fluoride will be smaller. Alkyl fluoride are less reactive. Related to this we can say the alkyl fluorides are less reactive than chloride. This is because bond length of fluoride is smaller. The bond length of the fluoride is smaller. So bond energy is higher. So bond energy will be high. Therefore they will be stable, more stable. Okay. Alkyl fluorides are less reactive than chloride because bond length of fluoride is small, because size is small, no, atomic size is small for fluorine. So bond length of fluoride is smaller. Okay, so the bond energy is high. Because of high bond energy, there will be stability. So this reason I have given for the order. And also alkyl iodides on standing become violet, because what will happen? No, they will decompose. Alkyl halides, the alkyl iodides, they decompose because the stability is very less, least stable. So they will easily decompose. Being least stable, they decompose easily in the presence of light, and iodine is produced. Iodine is produced, so they become violet. So both the reasons are interrelated, you can see. Next, let us answer some questions. One is, what is the order of SN2 reaction of alkyl halides? Means how in iodides, bromides and all this, if we compare the alkyl halides, what is their order? In decreasing order, if we arrange them, order of SN2 reaction of alkyl halides is Ri, the order is like this for SN2, Ri greater than RBr greater than RCl greater than Rf. Now why it happens? Because iodine is a good nucleophile. This happens because iodine is a very good nucleophile. It's a good nucleophile and a very good leaving group. It's a very good nucleophile and a very good leaving group. So it eliminates easily. So this is the reason. Next is little different flavor. One more question. The number of structural and configurational isomers of a bromo compound C5H9Br. It is formed by the addition of HBr to 2-pentyne. And for this compound, we have to find out the number of structural and configurational isomers. So let us do it. So first we have to write 2-pentyne. 2-pentyne. Addition of HBr to 2-pentyne gives 2 structural isomers. So let us see what is 2-pentyne, how we write. It is CH3, C, triple bond C. The triple bond should be with second and third carbon because it is 2-pentyne. CH2, CH3. This is 2-pentyne. To this, when we add HBr, we will get 2 products. CH3, in one case this triple bond will break, okay, and in one compound bromine adds to second carbon, hydrogen to the third. The reverse occurs in the other one, hydrogen to the second carbon, bromine to the third. So one will be CH3, CBr, double bond CH, CH2, CH3. This is one. And the other one is CH3CH, double bond C, to this third carbon bromine is added, CH2CH3. So this is the second one. These are 2 structural isomers. So these are what? two structural isomers. These are two structural isomers. Each of these will exist as a pair of geometrical isomers. Exist as a pair of geometrical isomers. So overall what we will get? There will be two structural, as I have drawn above, and four configurational isomers. So finally we get two structural and four configurational isomers. I hope students, all of you could understand the questions I discussed today. Thanks for watching my video. Please subscribe to my channel and share these videos. Please subscribe to the channel. Thanks for watching. Thank you.